It's recording now. Thank you. I always forget that. Appreciate it. So we have this. Looking for the givens, we have steel bar on springs, and this is very common. Not very common, but can be common in machine design. It's when you have two rails or a rail, and you have a force, and it's going to be. It's not always going to be on rigid bodies. So first, we have this kips. We're going to say K is equal to 15 kips per foot. And then what we have, it's originally unstretched. The bar is loaded with a force of 3 kips. You can say that force is equal to, actually let's call it P. P is equal to 3 kips. Let's see. Then we have an E and an I. For steel, we have the E for steel, which is equal to 29 times 10 to the third KSI. And then we also have the I, which is 12 inches to the fourth. What else? Okay, so we have, what I'm going to do is I'm going to say that A is equal to 3 feet, and that B is equal to 6 feet. Can you all see that? It looks very small on my board, but I just want to make sure.
I can see it.
Molly, can you see it?
I can see it.
Okay.
Although the top is like a little bit cut off. The top right?
The top right? Top.
Like A equals and B equals.
That's A equals. Can anyone else see that? Because I see that.
You need to maximize your screen.
Are you talking to me?
Yeah.
Yeah. I can see it well. Mine's full screen.
Awesome. Thank you, Lee. Molly, did that help out?
Yes and no. I can't figure out how to do that on my iPad, but it'll be all right.
Oh.
I don't know how to do it on an iPad. But nice. And I don't know how to adjust it on my end. But if we keep going, thanks, Molly. If we keep going, let's look at what we're trying to find. We're trying to find VC, this displacement at C. So first and foremost, we're going to do a free body diagram. Of this. And we have force A here, force B here. And then we have this P here. Also, we have, yes, we have a question?
Sorry, I had a hiccup.
Oh, no problem. Mal, if you want to mute, so we have an A here and a B there. So we have distances, and that's our free body diagram. So let's go to these different cases. So case 1, what I chose for case 1 was just treating this as a rigid body and having this being our original. And then I'm going to over-exaggerate this. And that being our after P has the form of this. So let's just take a look at the displacements of this. So on one end, we have from here to here, we have the displacement at B. From here to here, we have the displacement at A. And I'm going to put displacement at B1 for case 1 and the displacement at A for case 1. What I also did was this point C up here, it also displaced. And that I put that as VC1. So let's take a look at this case and start to solve this. Now, if you work out the math, we have, using static analysis, the solution, we can say that FA is equal to 2 kips and FB is equal to 1 kip. You do that by sum of the moments, sum of the forces. You should know how to do that. Well, let's take a look. How do we get VB1? Well, we know that in VB there's this spring, and we know the constant is equal to 15 kips per foot. So when that spring compresses, we can say that force times displacement, the displacement times this K value will give us this force. Or we can say the displacement at B1 is equal to the force at B divided by K. And that'll give you an answer there. And everything is known from that. Similarly, we can say that VA1 is equal to force at A divided by K, and that'll give us another answer. Now, here's where we can get tricky or not. What are our units if we just did this straight out of VB1 and VA1?
Feet.
Yeah, it's in feet. So we have to be very cognizant of that. Because we have feet here, we have feet here, and feet here. But in E and the I, we have inches. So depending on how we want to give our answer, is depending on how we proceed. I'm not going to work this out for you right here. Let's see what I have. So what I did was I actually worked out the E, and I got this E in kips per square foot. And I also got the I in feet to the fourth. And that's how, then everything else should be in feet from there on out. So if we do this, to this, we would multiply by 144, and that would be inches squared over feet squared. This would get multiplied by, or divided by, I should say, divided by 112 inches to the fourth. Then we left with feet to the fourth that way. So that's 12 times 12 times 12 times 12 to get it into feet to the fourth. Anybody have any questions with that? I know that's simple, but it's a misstep by some students. So if we do this way, the inches squared cancels out this way, and the inches to the fourth cancel out, and you're left with only in feet. So we're going to get answers into the feet. So once we get VBA and VB1, and VA1, we can find VC1. We can find VC1, but be very careful. As Salo pointed out, VC1 is a triangle, what I called VCA. VC11 and VB1. So down here we can say that VC1 is equal to VC11 plus VB1. Does that make sense? Just yes or no would be good.
Yes.
Yes?
Yes.
Okay. So we have VC11 now. And that's just a similar triangle. So we have V. Hold on, that's my music for some reason. We have B over A plus B, or 2/3, times VA1 minus VB1. And we can get an answer here. And then from that, we have everything that we need to get an answer from there. And that's how we would start with VC1. And VC1, I got an answer. Oh, I don't have it. I have it on MATLAB. 1 second. VC1, I got an answer of, since we can also say that this is positive, and we know that that answer is negative 0.111, and that's in feet. Anybody have any questions? Nope. I'll wait. All right. Now comes the other part. Which kind of we're all familiar with, which is case 2. And case 2 is taken right directly from the back of the book. For this A, this is the we have P, this being C. So right from the back of the book, actually, the way I did it, we can do a couple things. One thing is we can say that L is equal to A plus B, and that's equal to 9 feet. And then we're just looking for what we call VC2 at that point. And then we could say that VC2, using our table, we could say that VC2 is equal to minus P AB divided by 6EIL multiplied by L squared minus A squared minus B squared will give us this. And this is directly from the table. And I have an answer. VC2 is equal to negative 0.0149. So this displacement is an order magnitude smaller than this displacement here. The displacement at C and also the deformation. So anybody have any questions?
When
Could
you
move your screen?
I'm sorry?
Sorry.
Did
Could you move your screen over slightly? Because I can't see it all.
Oh, you can't? Which one? Oh, did I move my screen?
Yeah, so I can't see case 2 all the way. Thank you.
Oh, no problem. Thank you. And this is in feet as well. Somebody else had a question as well.
Oh, I was about to ask about your units on that.
Oh.
So it's good now.
Yeah. But if you notice, there's still a order of magnitude, which is important. You get most of your displacement from these springs, not from the beam deflection or this spring. And then we can add them together. VC is equal to VC from case 1 plus VC from case 2. And then we can get an answer of what did I get an answer of? Oh, I didn't finish the problem. Hold on. I can cheat. Oh, no, I'm not going to cheat. VC is equal to VC1 plus VC2. And then I get a final answer of negative 0.126. And that's in feet. Anybody have any questions? If not, you're free to go, but I do want to meet with the course improvement committee to see how this went. I don't know how this went. I need feedback from you guys.
I got a question, Dr. Fagan.
Yeah, sure.
Sorry, you're cutting masonry.
Wait till everyone starts to leave, and then we can. All right, looks like the majority of them left.
I had a question about the problem.
Say though.
I had a question about the problem.
Okay.
So I didn't get